2 electric generator needs. So it's a fully automatic operation. Your operators don't have to go down and touch it. They don't have to go down and make any adjustments to it. It's a constantly operating, functioning, self-monitoring piece of equipment. And again, as far as making breaking connections, you make the connection once to your hydrogen manifold. You're not moving things around. It's installed once. It's essentially an appliance. Related to gas inventory, large chute trails, again, 100,000 cubic feet. Lots of potential for incidents in that situation. If you have a large hydrogen storage facility and you have it valved into your electric generators on a regular basis, if you had some upset in that supply path to the generator cavity, a leak in your hydrogen piping, an issue with a pressure regulator, you have 100,000 cubic feet at 2,400 psi that could potentially go through that leak path, go through a failed regulator assembly, and end up inside a building or inside your plant. A hydrogen generator has an onboard inventory at the most of 1.5 standard cubic feet at any time for full production. So if you had a leak inside your building, the only significant, the maximum amount of gas that's going to go through that leak is what you have in your hydrogen manifold to your plant, 1.5 from the hydrogen generator, and that's it. You're going to see a dip in the hydrogen manifold pressure very rapidly, and your operators would be aware of that. With a large inventory solution, that 100,000 cubic feet is going to have to go through that leak or failure point before you see a dip in pressure. Does that make sense? So it gives you a great sense of security and awareness of what's going on with your hydrogen manifold system and its integrity using on-site hydrogen generation. So, how do we generate hydrogen? I remember back to your early chemistry courses, either in late middle school or maybe early high school. It's all about electrolysis. Again, take a water with soluble salt in its simplest form, apply a DC current. The anode, oxygen is generated, produced. The cathode, hydrogen is generated. And again, it's simple reaction. H2O becomes 2H2 and 1O2. So that principle has been refined by our organization. The founders of our company actually came from Hamilton Sunstrand, or what you may know as Hamilton Standard in the past. They're the manufacturers of spacesuits, space systems for NASA. The technology we're using started with the Mercury space program and has evolved, obviously, to a commercial product that's been streamlined, cost reduced, mass producible, to a system that now has gone from the military aerospace side to commercial production, and now we've come full circle and are going back into the military production, military infrastructure side by using our assemblies to generate oxygen for submarines. So the U.S. Navy, French, Spanish, and British Navy are all considering the use of our systems via Hamilton Sunstrand for oxygen generation on submarines. And those contracts have been signed, I believe, with a number of the navies. And the U.S. Navy, I think, is the one holdup, unfortunately, at this point. The core technology is essentially, again, the electrolysis process. And it starts here with a membrane electrode assembly. This membrane assembly, you can see, is about the size of your hand as far as diameter goes. And that's essentially a piece of Nafion. Nafion's a DuPont material, special polymer, special formulation. To that is bonded a mix of anode cathode materials that act as the conductors for the assembly. And those assemblies are built up into a cell stack. So this cell stack has 34 cells. As you add cells, you increase your generation rate, generation capability. Our cell stacks range from 10 cells, 20, and then the 34 cell stack range. Related to this, The generation rate is also controlled by the amount of current you apply to the cell stack. So I talked about the controls structure of the hydrogen generator. Essentially, that control structure is controlling the amount of current sent to the cell stack. The number of cells dictates the maximum amount of hydrogen you can make, or maximum production rate. And then if you vary the current to the cell stack, that varies how much hydrogen is made at any one point during the process. And that the individual cell stacks are built and assembled into a hydrogen generator and integrator. Essentially, the left-hand side of the cabinet is all your plumbing, hydrogen generation, oxygen management, plumbing connections here, and the right-hand side is your control system, power distribution, power rectification. It's all one complete cabinet, again, one-stop shopping essentially for on-site generation. For the power industry, we have three items that we support and provide to the power industry. The two on-site hydrogen generation systems, both the S-series and the H-series systems. And then in conjunction with on-site hydrogen generation, we've gotten into hydrogen monitoring systems for power plants as well. And the stable flow system is unique in the industry, and then it monitors hydrogen purity, dew point, and pressure in the electric generator cavity, and makes adjustments to the scavenge rate automatically to improve purity, reduce dew point, and maintain pressure inside the electric generator cavity. And I'll talk a little bit more about that as we go along. The S-series system has been typically rolled out in CT applications around the country. It's a single-phase power supply type system. It's an air-cooled system, quite compact for being air-cooled. Again, fully integrated design, connect up the utilities and it will generate hydrogen for you. Up to 1,000 cubic feet per day in the largest version. Again, 5 nines purity, dew point of -85 F or 5 parts per million equivalent or better, and at a pressure up to 200 psig. So certainly meet any needs you might have for generator cavity pressure, and that would just be stepped down to meet your manifold pressure needs. The H-series system, again, fully integrated design, 3-phase power, 380 480 volt AC input. It's a water-cooled system to keep it compact. So again, matching up with your existing utilities from the plant, you can just connect it into your existing ACW system, and the hydrogen generator does the rest. It has onboard temperature control to maintain the optimum temperature of the system while operating, and again, just takes that cooling capability from your existing infrastructure. Again, fully integrated, and it's also network ready, just like the S-series system. In other words, you can connect it into your Ethernet, your internal intranet, not connected to the outside world, but just your internal intranet. Bring it up on your local computer. You would give it an address just like you would your computer on a network. Bring it up and look at flow rates, generation rates, health monitoring, all those type of things. You also can record data over time, things of that nature. So it's, again, fully network ready. Production rates up to 5,000 cubic feet per day, and the generator is designed to be upgradable in the field. So you could purchase an initial generator that might be a third of the size, third of the generation rate. And if later that plant expanded, or you found you had a need for more hydrogen generation, you could expand that in the field, add an additional cell stack, set of power supplies, upgrade software, and you're up and running. And that's literally a 6-hour process, worst case. Similar hydrogen purity outputs, 5 nines, 5 parts per million, dew point or better again, and 200 psi output, and also 400 psi output, which we found more useful overseas. The next is a stable flow system. Again, in parallel with the idea that we generate hydrogen, we also want to manage hydrogen. Hydrogen management inside the electric generators is critical from a purity standpoint. The purity can add up to significant costs over time. So the stable flow system was specifically designed to monitor purity, dew point, and pressure inside the electric generator. And then report that information out to your DCS so you can make either adjustments